Cool. All right. So welcome to lecture again. This is Angular Part 1. There'll be 3 parts. We'll break this up into 3 different lectures. So this is going to be more of like an introduction to Angular, just to get really a feel for what this framework is that we're going to be stepping into and interacting with quite a bit. So just building familiarity, I guess you could say. I already did that. So why Angular? A bit of background on Angular. Angular was predominantly created by a team at Google, and it's actually still being maintained by Google today. So I'll be honest, as a developer, I used to think of Angular as being sort of like an archaic framework. And that's mainly because it's existed for a long time. So there are versions of Angular that are archaic. However, the most recent version of Angular was updated yesterday as of 8 p.m. I actually had to update the slide because the slide used to say it was updated 3 days ago, but then they updated it again. So they're constantly developing and making Angular better. I think we're up to like version like 14, 15, 16, 18, somewhere in the teens. Few websites that were written in Angular, just to kind of get an idea. Gmail is probably the best example of a website written in Angular. Gmail really is mostly like a single page web application. So you have a lot of stuff happening all on one page. And there's a lot of interaction, there's a lot of real-time updating. And so something like Gmail is a really good use case for Angular. Also Forbes' website, Upwork's website, IBM's website, PayPal, and Samsung's homepage. These are all sites that were written with Angular. So, I mean, there's the question of like why Angular, but there's also, I guess, the more meta question, which is why a framework at all. So, if we think back to the lecture we did, or the studio we did, where we were essentially manipulating HTML and JavaScript for the astronaut data, if we remember that, we were sort of, as developers, sort of like in the very beginning stages of creating a framework, like a web framework, because we were basically creating these chunks of HTML in JavaScript, and then we are injecting them into the page. And so that sort of, that sort of concept of using JavaScript to generate HTML or using JavaScript to inject data into HTML. When we scale that with, let's say, more of a complex application, that really creates the need for a framework to manage all that. And so I'll give an example here. So if we consider the footer on the LaunchCode website, so here's some HTML rendered to us, the users of this web page, and we've got a bunch of different items here. Now, if I change pages, hypothetically, I just loaded up a new HTML page, but we still have the same footer with all of these items in here. And if I change pages again, the same footer is here. And so it says copyright 2023 at the LaunchCode Foundation. Let's say it's 2024 now, and we need to update this one number right here. If this website was just created using regular HTML, we would need to go to every single page, every single spot, and change the value in the footer for every page, if that makes sense. If we're just using static HTML, every page would have a copy of the footer, and it gets very difficult to manage. If a link breaks and changes, you have to change it in 10 different places, and so it's a bit messy like that. But using things like frameworks, it can help us manage this and to generate maybe the footer dynamically, and then use that footer in multiple places, etc. So something to think about. So we talked about this briefly during the Kahoot, but AngularJS is, in relative terms, ancient. It is not the same as when we say Angular, we're not talking about Angular JS. We're talking about Angular 2 plus. So anything besides Angular 1 is what we mean by Angular. Angular JS is extraordinarily different than regular Angular. One of the biggest differences is that Angular 2 plus, the stuff that we'll be working with, uses TypeScript. And that was one of the big reasons why we were learning TypeScript, is because Angular uses TypeScript. Angular JS, if you see code examples that don't have TypeScript in them, it may be Angular JS because it wasn't originally configured with that. Also, I've got the logos up there. So usually Angular JS has like a gray border around the logo, and we'll mention like JS. So just be on the lookout for that as you're looking at resources, that you don't go down a rabbit trail looking at the wrong stuff, because they're very different. So kind of like what we were talking about with the website, the LaunchCode website, that footer. It would be really nice if we could reuse components on a web page. Like if we could reuse a footer. We can't do that with normal HTML, but with Angular we can. We can create something called components, and we can use them in multiple different places. So in this graphic we have an example. It's a very generic icon type of a web page, but we can see there's different things pointed out as components. We have like the banner up top. We have these buttons with like text underneath them, and those are all multiples of the same component, but probably with different values. And so with Angular, we could hypothetically create a component, put it in multiple different places, and then just feed it different values. Right. So the next 4 or 5 slides, we're going to be looking at the Angular file structure. There's a lot of files. Once we create an Angular app using something like ng new, and then the app name, you'll notice there's just a ton of files, especially if you haven't seen an Angular project before. And this is just the baseline stuff. It can be a bit overwhelming at first, so we're just going to try to take it slowly and get a feel for what really is in this file structure. So at the project level, so this is the folder that your entire project lives in, there's essentially 2 key things happening here. We have our src file, or source file. That's a very important, folder. We have our src folder. That's a very important folder. In addition to that, we have these configuration files. And so we'll have things like the package.json, which we've seen before with other projects. This is keeping track of all of our node modules. We have a TypeScript config file, all kinds of config files. A lot that aren't really listed on this slide, but to sort of map this out cognitively, in the main folder we have our config files, and then we have a folder with everything else. Those are the important things. Now, once we dive down into the source folder, we have the app folder, very important folder that's going to contain all of the app files, all the visible components. In addition, we have an index.html inside the source folder, as well as a TypeScript file and a style file. Generally speaking, these are essentially more like config files. When we're working with our Angular projects, we're not going to be editing these files so much. The actual development of all of our visible components and stuff is going to happen inside the app folder. The assets folder is going to contain everything like our images and different documents and stuff that we might need to reference in our app. Like, for example, if there's a school website and they have a PDF that was like an enrollment form, you might put that in the assets folder and then reference it throughout your app. Now, once we dive down into the app folder, we have sort of our root app component thing. And so in here we'll have our There's like, we'll look at the files more in depth, but we have our CSS, HTML, and then TypeScript. In addition to that, we can have a bunch of components inside of our app folder. And so the components will just have like a CSS, HTML, TypeScript, pretty standard combination of files. But what's important to know about the components is, while app can have a bunch of components in it, your components can have components, and those components can have components. And so we can kind of develop sort of a, I don't know if fractal is the right word, but sort of if you like imagine like a family tree where a component can have a component which could have multiple components. You can kind of like spread out the complexity of an app by breaking it into the components, and this is sort of the structure that they live in. I don't know if I said that in the best way, but that kind of concludes like my description of the Angular file structure. I'll pause here for questions, maybe on how I like questions on like what I was just described as far as the file structure, or just anything else about Angular so far. Yes.
So would you say like the chat window that pops up on Facebook when you're on a computer?
Mm-hmm.
You basically said that would be like, for example, one component that probably has several components therein to manage the chat window separate from the page content that you scroll through.
Right. So it's like on Facebook, you're talking about like the Messenger chat window.
Yeah, because like normally on Messenger, like if somebody messages, you might pop up at the bottom right corner.
Oh, okay. Yeah. So this is a good question. And it's basically, the question is pulling from a real world example, which would be Facebook. And so sometimes like term like a Facebook notification that pops up.
Or even like sometimes an actual chat window will pop up in the bottom right. But
Okay.
Keep scrolling, you can minimize it, keep scrolling.
Right.
But like that always seems like you behave differently than the rest of the site.
Sure. So yeah, with this question, we have like the Facebook website, and then we have like a chat window that pops up in the bottom right hand corner. It's sort of disconnected from the rest of the website. That's a great example of what you probably want to be its own component. And with a site as advanced as something like Facebook, everything, including like a Facebook post, is definitely going to be its own component. Especially if it was written in Angular, that would be its own component. And within, let's say, hypothetically, if we imagine a Facebook post, you'll notice there are like a like button, and there's a lot of different pieces. There's a share button. Given how much there is that goes on with just a Facebook post, that is probably a component which contains several components. If a button is complicated enough, you can make that its own component, hypothetically. So yeah, it's really all about breaking up the complexity, right? If you imagine in JavaScript writing a giant function, you could write it as a giant function, or you could take pieces out of it and make those smaller functions. And so you don't have to break things up into smaller components, but as an application grows, it makes it more manageable, right? Cool. Thanks for the question. Other questions before we move on? Yes?
How would you describe a component to like a 10-year-old kid?
That's a good question. How would I describe a component to a 10-year-old kid? All right, so imagine a Lego ship, Star Wars Lego ship. The Lego ship is one thing, like a website, but it's made up of many pieces, and so a component may be a piece of that. Or if we imagine like a house is made up of several components. We have walls, which may be a component, and the wall may have a door component as a part of it. It might have a window component. And so there are all these different components that make up the whole house, which would be analogous like a website. So hypothetically, you could 3D print a house all in one piece. And that would just be like one component, right? It's not broken up into other components because it's just all one solid piece. Or you could build it, you could build a wall, you could add a window. Does that make sense? Like how that might work out?
So it's like nav.component.css is one component, and inside that file it has other components. It's like pieces, basically.
Right, so in the example on the slide, the navbar folder would be the component. And it's made up of its three files, which is going to be its CSS, HTML, and TypeScript. So previously, when we looked at examples of a website, they typically made up of CSS, HTML, and JavaScript. Here we're substituting JavaScript for TypeScript. And so another way to think about a component could almost be like thinking of a mini website living in its own folder that you're using in your larger website. Might be another way to think about it. Right. Cool. Good questions. I'm glad we're clarifying the whole idea of a component. Other follow-up questions to that, or anything else? Yes.
So with the template then, is it just that's the blueprint and the components?
Let me see if I understand your question. The question was with the template.
Oh my.
Okay. Let me think here. So I'm actually not totally caught up on templates in Angular, so I don't know if I can answer that like in a way that would be beneficial. Let me follow up on that one. That's cool. But thank you. Cool. Awesome. Other questions? Nope. Moving on. So quick Angular command line interface cheat sheet. So you've probably seen all these commands, and when you create a demo React app, or not React app, Angular app, it will give you a few commands in there as well, just in the demo page, which I thought was kind of a cool thing. But to create a new app, it will be the ng new name of app. If you add weird characters, it will give you a warning and explain how to fix it. So it's kind of particular on what characters go into your app name. Additionally, so there's flags that we can add to commands. We've seen a few of these flags in just, for example, like a git command. If we say like git commit -c, and then we add our comment, that -c is like a flag, which allows us to then add on the comment. With Angular commands, they're very similar in that we can add flags to them. So for example, if we create a new app, it's going to create a Git repository when we create it. However, if we don't want to do it that way, or maybe we already have a Git repository that we cloned from GitHub, we can create a new Angular app and just say --skip-git. And so there's a couple different flags for Angular that you can look up, like that. Also, so let's say we create a component, or we create a React app. Now we want to add a component. I don't recommend trying to create a new component just from scratch, unless you want the practice figuring out like how the syntax looks. Instead, I'd recommend using Angular's command to generate that component. So what we can do is we can say ng generate component and then the name of the component. That can be shortened down to ng, G for generate, and then C for component, and then the name of the component. Also, if you remember a moment ago, we were talking about creating components within components as a concept. Hypothetically, we can really break things out like that. If you wanted to generate a component within a component, you'll need to navigate in your terminal to the component folder and then run this command. So it's not really on the slide, but a comment. I looked up why Angular's command line command was ng, and it's some developer's idea of how to concatenate the word Angular. So A, N, G, and then the rest of the letters. So they just said, well, Angular is shortened as ng. I don't get it, but that is what we have, in case anyone was wondering. Cool. So starting up an app is going to be the command ng-serve. And like the other command, we can shorten it, the command, to just S for serve. And so this slide you can reference. This is just the commands we just spoke about all in one slide. And then also, so we're going to generate a new app. I'll just do it live, and then we'll add a component and mess around with it a little bit. Before I do that, I did want to talk to, I guess, some of the issues installing TypeScript and Angular, because I know that that's been a bit of a rocky road for some of us as far as figuring out how to overcome different issues with our installation process. So the two different things, I guess, I wanted to draw a picture for you, so that when you're starting to debug it on your own, you have an idea of what might cause what. So the first thing that's happening with something like an installation of TypeScript, so let's say we install npm install TypeScript, and we have -g for global. What happens behind the scenes is npm goes up to the internet, it grabs the files for TypeScript, the TypeScript language files, and it installs them on our computer. And then there's some magic that happens that essentially creates something that's like a shortcut between the TypeScript command and the TypeScript language. So, for example, when we, on our terminal, if we were to type in for Angular, like ng, and then a command, that ng command is linked to the global install of Angular. And so it's like a hyperlink, but it's happening kind of deep in the background. If that hyperlink, for whatever reason, I'm calling it hyperlink, if that gets broken, then even though we have it installed, it's going to say command not found. And so in some instances, what I think may be happening is that you've installed Angular or TypeScript, and then you go to run the command, and it's not found. And that's just because that link got broken. Now, the follow-up thing that you may try is, instead of installing it globally, you attempt to install it locally. So npm install Angular without the -g. If you were then to try to run the like the ng commands, it's not going to work, because that is not creating sort of the hyperlink between the command and the code. And so a workaround that I've posted, I guess, in the general channel is there's something called npx, and npx will allow us to use things like TypeScript or Angular within a local project. And so this is a workaround in case we're not able to resolve the issues with the global install. So if we're not able to resolve those, a workaround would be to install either Angular or TypeScript, whatever we're trying to work with, within our project. So npm install Angular, and then we can add _save -dev. That part's pretty much optional, but that would save it locally in your package .lock or .json. From there, we can prefix all of our commands with npx. And so npx will allow us to run things like Angular or TypeScript within a local context without having to rely on this global context that on some machines has gotten messed up. So I've said a lot. I don't really have a slide to help make this a little bit easier to digest. So I'll take questions on this, the whole concept specifically of using npx as a backup plan. Yes?
So when you say that we're going to save it like in a file, and you keep all of your coding projects?
So when I maybe you could do that, but when I say locally, I mean local to the project. Then when I say globally, I mean globally to the entire computer. So and this can be useful if you ever needed to use multiple versions of like TypeScript or Angular to use this npx method, because you don't have to install it globally. But essentially, so let's say you have example project A. Within the example project A folder, that is where you'd install Angular or TypeScript locally, and then that is where you'd run the npx and then the rest of that command. Right, thank you for that question. Cool, follow-up questions to that or other questions? Yes?
I have managed to download and install Angular 3 times on my laptop.
Mm-hmm.
You got any tips on how I can figure out how to get back to Angular? Is it okay to have 3 separate versions somewhere?
3 separate versions somewhere. So if we think back to the concept of like when we install Angular, it's basically hyperlinking that command in our terminal to the install files. It can't have 3 different versions hyperlinked at the same time. It's either one of them is linked when you type in the Angular command, or none of them are. Probably the latter, none of them are. As far as tips beyond that on how to fix it, I can't really say anything specific without knowing more context. Which we might be able to do something one-on-one to help resolve that. Cool. Awesome. Other questions? No? Cool. All right, so let's create a new Angular app from scratch and see how this goes. So you'll notice I'm using git bash. Generally speaking, I prefer using git bash over the terminal inside of VS Code. I don't really have any empirical evidence to back this up, but generally speaking, I have seen weird issues show up with the VS Code terminal, and I believe the reason for that is it's basically emulating the bash terminal, and it's not actually a bash terminal. That's the same thing happening here. Never mind. I won't go off on that rabbit trail. But generally speaking, I recommend using git bash to interact with our projects, to install stuff, etc. So let me navigate to my projects folder where I like to keep everything. And so from here, I do have Angular installed globally. So I can run Angular V, I believe is for the version, although it's stalling. Right. So it looks like globally I have Angular 12 2.18 installed, then I have Node 14.19 installed. It's an older version of Node that I needed to install in order to work with Angular 12. Node 18 was giving me issues. All right, and so ng new, so we'll call this, what would be a really good name for an app? I don't know. We'll say Facebook, just because that's sort of an example. We'll pretend we're creating Facebook, although we will not succeed this evening. Cool, so these are all the files it's creating. And that's a lot of files just to have the boilerplate for an app to run. Some of them are more significant than others. Like as this is installing, I'll point out the favicon right here. That's the icon that shows up in the tab in the browser. So for example, on LaunchCode, we have the little rocket ship up on the tab. I don't know if you can see that. And so that's what the favicon icon file is. So not super important, but it's one of the many files we're installing. And so now that it's basically added these files, it's now installing the npm packages required to run this app. Once again, to the language of talking about installing something globally or locally, it's installing these npm packages locally. And the way we can confirm that is by looking into the project. We'll see where it installed them. So let's say cd Facebook. All right, so now we're inside of this Angular app that we just created programmatically. And speaking to when we install npm modules, there's this grayed out folder right here called node modules. And this is filled with everything it installed for this one project, local to the project within the folder. there's a lot of stuff in there. I haven't finished scrolling, but I'll just go back up and close it. It's always shocking to me seeing like a more of a developed project to see how many node modules it has. It's insane. Thousands of these little bits of code that are installed from various places on the internet. But anyways, so during the lecture we talked about, so we're inside of our project folder. The project folder is called Facebook. And then in here, the important things is we have our configuration files and we have our source, where all of our visual components are gonna basically live underneath that source folder. We have our package.json. This has all of the different npm packages that we just installed under dependencies right here. And under dev dependencies. We don't need to really go too far into understanding that. But I will point out there is an object that you'll see in package.json files called scripts. And scripts are essentially shortcuts. So if we were to run npm start, it's going to actually run the command ng serve, which is going to start up the application. All right, so we don't need to worry ourselves too much with the config files. Let's look inside of the source. We have our icon, Angular icon. We don't really care about that right now. We have a polyfill file, which we're not going to worry about. And then we have our index file. And here I'm going to point out app root. It's this component. Let me make that a little bit bigger. Not that much. We have app root, and this is essentially this represents our Angular app is going to be right here. And so that's why I sort of consider this file more of a configuration file, because all of our Angular code or HTML and TypeScript stuff is essentially represented by this right here. We have an assets folder, which is currently empty. This git keep in there is basically telling Git not to delete the empty folder. And then we have environments, which we're not going to worry about at the moment. Real important folder that we've drilled down to from our project folder to source. It's finally to app, and this is where we have our main file. There's a lot in this. I guess we could call it demo HTML. They have all of their CSS, or a lot of their CSS inside this file, which honestly could live in this file. I'm not sure why they did it that way. And then a bunch of demo HTML. So let's actually look at what this is generating so we can make more sense of the files. So this just compiled the TypeScript, the Angular code into ES 2015. I believe that's ES 6, I think. We've talked about it in passing. It's not super important for this conversation. What is important, though, is where did it send this Angular application? And so I've just, I guess, spun up the application. But how can I actually view this Angular application? I'll pose this one as a question. Someone tell me how I can view this. Right. So I can go to localhost at 4200. Right, and so this demo Angular app that we just spun up, it contains all of the code to make what we're looking at right now. So that's cool. And if you also notice, it has the name of our app right here. And so that's kind of curious. How did they do that? Did they hard code that? Did they use some Angular magic? Let's answer that question real quick. How did they get the name of our Facebook app right here? So we're actually already right here in the code. You'll notice the text, this app is running. And if we look over here, we have app is running. Not this app, just app is running. And then we have some strange text right here. So we have 2 curly brackets, 2 curly brackets, and then something called title. I lost my stuff. Cool. So the next file we're going to look at, we're not going to concern ourselves with the spec file. This is for tests. We'll worry about those at a different time. But we do care about this TypeScript file right here. So we're in the main app component. And inside of here we have a class. And inside of the class we have something called title. And the title that they're giving it is Facebook. And so here, essentially, we have the property title, value Facebook, and in our HTML, we have title referenced here. So that is how it was able to automatically generate Facebook right there. And so we'll see a lot more of those types of examples in the future as far as how to use the TypeScript to interact with our HTML-ified Angular or Angular-ified HTML. But let's edit one more thing. I kind of want to, what I want to do is I want to edit this element right here, top left, and just say welcome McDev, make it a little bit more customized. So I need to find out where it says welcome. It's right here. And if I just reference the other example, I could do something like, and I'll call this name. Now in my TypeScript file, I can just add name equals McDev. Let's see if this worked. So yeah, it's already updated. So it already says welcome McDev. So one thing you may really like when you're working with Angular is the fact that it will real-time update. We don't need to refresh or restart the page in order to see changes start happening in real time. So that's pretty great. Cool. So before we jump into the last little bit of the slides, there's not much. Any questions on what we're looking at right here? Yes.
When you were using the properties of the class, where did you call the class
So the question is, where was app component referenced inside of app component.html? So we can investigate this. Just as an example, I think the best way to do it would to show this would be to search for. So if you notice, I'm searching for app component and I'm not finding it anywhere in the HTML. And so what you might expect to find, based off of how we've used JavaScript in the past, you might expect to find something in the header importing it, but we have all the CSS in the way. It's making it harder to make the point here. But we have all the CSS in the way, and there's no actual header. We just have our HTML. Nowhere is app component referenced. So this is a really good thing. I'm glad you called it out, because what's happening here is the Angular framework is taking the files app.component and app.html and app.component.ts, and it is essentially like programmatically like combining them, and so we don't have to reference app component inside of our HTML, but we can reference these properties we created.
So what if you had two different classes though? You need to like reference. Like what if you had another class that also had the property type?
That's a good question. Let's see if we can make this work that way. One thing that might be a real important part of this is this at component thing right here that's referencing the HTML. But let's try this way. Nemo, there we go. My brain blanks out the weirdest things. I'll just call this. Let's see if this crashes things. If it's, nope. So it's loading, we can see up here. We're trying to. Let me see what my terminal is saying. It looks like it's complaining maybe. Error, failed to find exported name of node. Well, it looks like we broke it, essentially, creating this other class. To give a better answer as far as like exactly how we broke it, I couldn't tell you at the moment, at least not in a super intelligent way. But let's go back to using our original class. And then this should work. It's possible that we broke it enough that we'll need to restart it. Cool. Now we're back. All right. Thanks for the question. Cool. Other questions, other things we want to try? No? All right. Cool. So we had quite a bit of we talked about this quite a bit when we were just looking at the demo project that we created. But just to call them out again, the app component or any component we create is going to be generated with 4 files. It's going to have a CSS file that's just for styling, right? An HTML file, and this Angular gives us the ability to do more interesting things with it, like reference things like we saw with the name example. And then we have our bottom option right here, our component.ts TypeScript, and there we have our class that's able to basically have the different properties and values that ends up being injected into our component. And then finally, we have the component.spec.ts, and that is our tests for our TypeScript code. And actually, I know we were just looking at the React app. I do want to do one more thing with it, and that would be G for generate, C for component, and I'm just going to call this aardvark. We're just going to create a component called aardvark. And it's already done. I saw 404 bytes and I thought it was an error because of 404 code, but yeah, that's just my brain. And so if we look back at our code, we have the new folder in here called aardvark. This is the component that was just generated, and we can see the 4 files in here that we're going to have generated with each of these components: CSS, HTML, and TypeScript, as well as TypeScript tests. We'll notice that it pre-wired a few things for us. So we have this boilerplate class called aardvark component, and then it has this at component annotation. Annotations are probably a new thing for this class, I'd imagine. We'll see them definitely again in Java as a heads up. And then we have like these various attributes here that it pre-wired. And then we have our HTML. It doesn't have anything fancy in here. It just has a bit of text, and our CSS is empty. This is our test file. Sorry to blaze through here, but this is our test file. This is essentially just going to test that everything's working for the new component we created. And cool. So I wanted to show that mainly because we were just looking at the app component. We didn't look at like a child component of the app component just to see how similar they are in their files. This slide is probably more for reference, and this is if you create an app using the create app command. This is just a quick guide on deleting all of the demo content without breaking it. And so essentially everything inside of the app component HTML you can delete. And then the other thing you want to delete is just the variable that it puts in there called title, as well as the test that references that title variable. Once you have that deleted, then you're kind of starting from a blank slate. Cool, so that brings us to Studio. A note for this one, there's no starter code. So you'll create a local repository, then you'll link it to a remote Git repository later, and we'll be essentially creating a React app, or a Angular app. Sorry, I keep saying React. It's kind of where my brain has been at lately, but cool, awesome. Good luck on Studio, and I'll see you all at 8.